Let's talk about what defines an equation. So we've already talked a little bit about expressions. And now we're going to talk about equations. So a lot of times it helps to compare equations and expressions because they're similar but not quite the same. So we already know that an expression is made up of terms, and those terms are separated by a plus and minus sign. So something like 2x plus 5y would be an expression. An equation has something in particular, and that's an equal sign. It's in the word equation. The word equal sign is in the word equation. So an equation would not be 2x plus 5y. An equation would be something like 2x plus 5y equals 7. That would be an equation. So equations have to have an equal sign, and expressions do not have to have an equal sign. So if equations have an equal sign, that means that they can be solved. So the instructions would say something like solve. Expressions, because they do not have an equal sign, cannot be solved. They can only be simplified. Sometimes when you're given the variable, the replacement value of the variables, you can evaluate an expression, but you can't solve it. Solving is specifically the process of finding the value of x or finding the value of y when it's not given to you. So to solve equations, we're going to learn a little bit about what we call inverses. And inverses are operations that undo one another, that cancel each other out. So it's very simple, so don't worry. The inverse of the operation addition is subtraction, and vice versa. The inverse of the operation subtraction, see if I can write this correctly, is addition. The inverse of the operation multiplication is a division. The inverse of the operation division, just as you might expect, is multiplication. So here are some examples, just in case you're wondering. If I try to add things together and then I subtract, I'm going to start right back at the beginning. So let me show you how this works. Take a minute to copy this. Pause the video if you need to before you go on with the lesson. So here's an example of the fact that addition and subtraction are inverses of one another. So if I have 5 and I add the number 2, I get 7. But if I have 7 and I subtract the number 2, I get right back to 5. So the operation of addition and the operation of subtraction, they're inverses because they essentially canceled each other out. They both resulted in the same number of 5 when I applied addition and then applied subtraction with the same number. The same is true of multiplication and division. They cancel each other out. So take, for example, if I have the number 2 and I do a multiplication by 3, I get 6. So then if I start with 6 and I do a division by 3, guess where I'm going to end up? I'm going to end up right back at 2. So the operations of multiplication and division, when applied to the same problem but backwards, went ahead and undid one another, and I was left with just the number 2. And so when we're solving equations, we're going to use these inverses. So let's take, for example, the equation x plus 2 equals 5. It's an equation because it contains an equal sign. And it's an equation in which you have a variable of x, a number I don't know. 2 is added to that variable, and the result is 5. So I want to know what number, when I add 2, gives me 5. And I know you might already know the answer to this, but just follow along. So the operation, we're always going to look between the variables and the numbers. The operation here is addition. That is the operation I want to invert. And remember from the previous slides that the inverse of addition is subtraction. So I can only cross this equal sign. This equal sign separates the two sides of my equation by doing inverses. So I'm going to do the inverse of addition of 2, which is a subtraction of 2. So remember what we just learned. If I had x added to 2, and then I subtract 2, those 2's are going to invert one another. They're going to cancel each other out and leave me with just an x on the left side of the equation. And on the right side of the equation, I'm going to go ahead and actually subtract 5 minus 2. That gives me 3. So this gave me the value of x. It revealed the value of x, which was 3. And so you can check that, because when you have some number and 2 is added to it and you get 5, well, obviously that number must be the number 3. In more complicated scenarios, we're going to want to have a specific way of finding this unknown value. In this next scenario, we have that 3 multiplied by x gives me 12, and I want to look for the value of x. So the first thing I have to understand is that the operation between the number and the variable here is a multiplication. So I need to think back to the inverse of multiplication, which is division. So if I want to invert that 3 times x, what I need to do then is I need to do a division by 3. And whatever I perform on the left side of the equation needs to also be performed on the right side. So that multiplication by 3 followed by a division by 3 are inverses of one another. They will cancel each other out, leaving me with just an x. And a division of 3 into 12 gives me the number 4. So that is the answer, that x is equal to 4. You can verify that, because if you go back to the original equation, well, 3 times what number can give me, there should be a 12 there. So 3 times what number can give me 12? And the number is 4, because 3 times 4 gives me 12. We found that from the process of solving.